Okay, so the question is that we have to find the greatest integer less than or equals to this. We know that what greatest integer is. It is the integer which is less than the given value. For example, if I give you 2 point something something something, then my greatest integer for that will be 2. So it will be always an integer, only an integer which will be less than your given number. So now let us solve it. So it is asking for a greatest integer which is less than this. Now let this expression be equals to t. So our t is equals to root 2 plus 1 raised to the power 6. Now its greatest integer will be t in square brackets. We have learned it that greatest integer function is represented by the variable and enclosed in this square brackets. Now we know that this is our greatest integer function. Now if we write it like this, greatest integer function plus some fraction will make up our this value again. So our value will be greatest integer function plus some fraction. Okay, let it be 1. Now if we see that greatest integer function is less than our given value, so if we write root 2 minus 1 raised to the power 6, so it has to be less than 1, but it will be greater than root 2 minus 1. Okay, so let us assume that root 2 minus 1 is equals to our f1. Okay, or you can write it like this, that our f1 is equals to root 2 minus 1 raised to the power 6. Okay, so we are having two equations here and let us add them. So adding 1 and 2. By adding 1 and 2, we will get t plus f1 is equals to t plus f1. So we know that what t is. T is nothing but this. So, oh sorry, this is not f1. Yeah, this is f1, but its value is written here. So it will be this. So t is what? Root 2 plus 1 raised to the power 6. So we can write it as root 2 plus 1 raised to the power 6 plus root 2 minus 1 raised to the power 6. Now we know that what is binomial theorem and we will solve it according to that. Let's solve it. Okay, so we are having this. So our greatest integer function t plus f plus f1 is equals to, first of all we are having this. So by opening this by binomial theorem, we will get 6c0. Our first term is root 2. So root 2 raised to the power 6. We will not write 1 because we know that anything raised to the power 1 is 1 itself. Okay, so we'll leave it. So we can write it as 6c0 2 raised to the power root 2 raised to the power 6. Next will be 6c1 root 2 raised to the power 5 plus 6c2 root 2 raised to the power 4 plus 6c3 root 2 raised to the power 3 plus 6c4 root 2 raised to the power 2 plus 6c5 root 2 raised to the power 1 plus 6c6 root 2 raised to the power 0. Now we have completely written the binomial expansion of our this part. Now it's time for root 2 minus 1 raised to the power 6. Now we know that expanding binomially this minus term, we are having a pattern of plus minus plus minus plus minus, and the a and b part in both the terms are same. So we can cancel it out. Let's see how. So we can write this term like it will be 6c0 root 2 6 minus 6c 1 root 2 raised to the power 5 plus 6c 2 root 2 raised to the power 4 minus 6c 3 root 2 raised to the power 3 plus 6c4 root 2 raised to the power 2 minus 6c 5 root 2 raised to the power 1 plus 6c 6 root 2 raised to the power 0. Okay, so we can do it orally as well, because these terms we can see that they are going to cancel each other. So, but I have shown you expandingly so that you can understand it well. So this term, this term, this term, and this term, they will cancel each other. See, it is plus, it is minus, and the terms are same. And we are having this term, yeah. So we are getting twice of this, and this. Okay, so let's write. So we will get our greatest integer function plus that fractional value plus our f1 is equals to twice of 6c 0 2 raised to the power 6 plus 6c 2 root 2 raised to the power 4 plus 6c 4 2 raised to the power 2 plus 6c 6 2 raised to the power 0. Let's solve it out. So we know that 6c0 is nothing but 1, and we know that root 2 raised to the power 6 is nothing but 8. So write it right, 8 plus we know that 6c2 is what? 6 factorial by 2 factorial by 6 minus 2 is 4 factorial. So by cutting it out, we will get it like this, and this will become 3 and this will become 2. So we are getting 3 into 5 is 15, 15 into 2 is 30. So we will get it as 30 plus this is what? 6 factorial by 4 minus 2 is 2. I'm just solving it out. So it will be 6 into 5 by 2. So it is 3, it is 2 plus this will be 6 and 6, it is nothing, it will be 1, because root 2 raised to the power 0 is nothing but 1, and this will also become 1. So this is our 1. So we are having 6, it was 6 factorial, and this was 2. Okay, so we are getting this. Great. So this will be our 15, and this will be our, so our root 2 raised to the power 4 is what? 4. So it was 4. I calculated it wrong, sorry. So it will be 2. This is 8 plus 60. 15 into 4 is 60. Plus we are having 30 plus 1. So this will be 68 plus 31 into 2 is equals to our greatest integer function, which we have to find, f plus f1, which is 2, and this is into, and this is 99. So 2 9s are 18, 1 2 9s are 18. So we have got 198. So our greatest integer function plus some fractional value plus f1 is 198. Now we know that this f was some fractional value, right? So it should lie between 0 and 1, and we know that our f1 is equals to this, and this is also a fractional value. So this f1 should also lie between this 0 and 1, and if we add both, what we will get? We will get this 0 f1 plus f less than 2. Why? Because 1 plus 1 is 2. So we have got this, that our f1 plus f is in between 0 and 2. Okay, so we are having this. Can we write it as f plus f1 is equals to 198 minus t? Like this. We have written this like this. We have taken this greatest integer part on our right hand side and we have modified it as f plus f1 is equals to 198 minus our greatest integer value. Now, if this is also integer and this is also integer, so if we subtract two integers, we must be getting an integer. Therefore, this value will be an integer. And we know that this is lying between 0 and 1. Therefore, this value should be 1 because in between 0 and 2, we are having only one integer, that is 1. Therefore, this integral value of f plus f1 which we are getting in this should be 1. Therefore, this f plus f1 is 1. So, 1 is equals to 198 minus t, and here we get our hero, which is greatest integer function t. So by taking this to this and this one to right side, we will get 198 minus 1, which is 197, and bingo, our answer is here. This was very big, but we can do it in few seconds as well via shortcut method. If you want that method, please let me know in the comment section below. Do like, share and subscribe. If you are having any doubt and any question, comment down your question below.